Okay, welcome to part 2. So if you haven't seen part 1, I would encourage you to go back and watch that video first before watching this video. Part 1, we derive Bayes' theorem, and we're going to go through the calculation of this formula right here in this video. So where we left off last time was that we have a bunch of these likelihood values right here. This guy right here, probability that the warden would say B, knowing that A would be pardoned, as well as these likelihood values in the denominator. So let's look at how to calculate these guys, and we will be able to conclude who was correct, whether it was A, who thought that his chances of surviving has gone up to 1/2, or if it was B, who thought that his chances of surviving has gone up to 2/3. So let's consider A's likelihood distribution. So A's likelihood would look like this. 0 and 1. Now, this right here is saying what's the probability that the warden would say B would be executed, knowing that A would be pardoned. This is what the 1 represents, that A would be pardoned. So if the warden knew that A would be pardoned, then he could have chosen either B or C to name, because both of them were going to be executed. So the chances that the warden would say B over over C would have been 50%. So we have 0.5 right here. Now, just for the sake of completeness, let's consider this guy over here. This is the probability that the warden would say B, knowing that A would not be pardoned. This symbol right here means not. So knowing that A would not be pardoned or A would be executed. If we knew that A would be executed, then the possibilities are A and B, or A and C. These are the only two choices as to who would be executed. So if it's if it's the first scenario, let's think about this. A and B, well, he would have to choose B. The warden can't tell A that he's going to be executed. Similarly, if it's A and C, he would have to choose C, because the warden can't tell A that he's going to be executed. Both of these are equally likely, so this is also a 50% chance that he would have named B knowing that A was going to be executed. Let's consider B's likelihood. So we have this guy right here, 0, 1, this 1. Alright, so what's the probability that the warden would say B, knowing that B would be pardoned? Well, that wouldn't happen, so that's 0. How about this guy right here? What's the probability that the warden would say B, knowing that B would not be pardoned, or that he would be executed? So then the possibilities are that B would be executed and A would be executed, or B would be executed and C would be executed. Okay, so let's think about this. If it's B and A, then the warden would have to say B, so that's 100% probability. Let's keep track of this right here. So this 1 means 100% for this scenario right here. How about this scenario? So then if it's between B and C, then he could have chosen either one of them, so that's 50%, so that's a 0.5. Both of these scenarios are equally likely, so we would need to multiply them by 1/2 to reflect that, to take the average. So then we would have 0.5 times 1, that's 0.5, plus 0.5 times 0.5, that's 0.25. So then that's equal to 0.75. So then this guy right here is equal to 0.75. Okay. Let's finally consider C's likelihood. And notice before that I had said likelihood distributions are not considered proper probability distributions, and you can see it right here. They do not have to add up to 1, which is why they are not considered proper probability distributions. They could add up to 1, as you see here, but they don't have to. Okay, so let's go to C's likelihood. Alright, so we have 0 and 1. So what's the probability that the warden would say B would be executed, knowing that C would be pardoned? So if we knew that C would be pardoned, then that means that B and A would be executed. But the warden cannot say that A will be executed. He can't tell him that. So then B would have to be the answer. So in this scenario right here, it'll be 100%. So that would be 100%. And then how about this guy right here? Probability that the warden would say B. Probability that the warden would say B, given that C would not be pardoned or that he would be executed. So then let's think through this. So if we knew that C would be executed, it would be C, it could be C and A, or it could be C and B. We can actually use this same calculation. It's going to be this same calculation right here. So if it's between C and A, then the warden would have to say C. So that's 100%. If it's between C and B, then the warden could choose either. So that's 50%. Both of them are equally likely, so there's 50%, 50% here. So this is also 0.75 right here. So this is 0.75. Okay, so now that we have the likelihood, we can do this calculation right here. These probability of A and probability of B and C, we already know what those are. So we have everything we need to work out the math. So let me copy this guy down here. So we have the probability of A given B equal to the probability of, what did we say it was? Oh, B given A times the probability of A divided by probability of B given A times the probability of A plus the probability of B given B times the probability of B, and then finally plus the probability of B given C times the probability of C. Okay, this is capital C. Let's do this, capital C. Make sure to indicate that this is the hypothesis. Okay, so then let's run through the math. So probability that the warden would say B, knowing that A would be pardoned, that's this guy right here, that's 0.5. So that's, let's do 1/2 times, what's the probability that A would have been pardoned before we were given any kind of evidence? Well, that's 1/3. Okay, divided by, so then this is also 1/2 times 1/3 plus, what's the probability that the warden would say B knowing that B would be pardoned? Well, that's 0%. So this whole thing would turn to 0. Plus the probability that the warden would say B knowing that C would be pardoned. that's right here, 100%, times the probability of C, that's 1/3. So that's plus 1 divided by 1, that's the 100% right here, times 1/3. Oops, let's make this a little neater. Okay. So then we have 1/6 divided by 1/6 plus 1/3. And that's equal to 1/6 divided by, let's see here, so if we multiply both top and bottom by 2, so then that'll be 1/6 plus 2/6, which is equal to 1/6 over 3/6, and that is the same as 1/6 times 6/3. These guys would cancel, so that's equal to 1/3. Okay, so the probability that A would be pardoned given knowing that B would be executed is 1/3. So it turns out that C was correct, that his chances of surviving has actually gone up to 2/3. So before we had 1/3, 1/3, 1/3 for A, B, and C. But since we know that B is going to be executed, then, and this has to equal to 1, then because A has a third of being pardoned, C has to go up to 2/3 now. His chances of being pardoned has gone up to 2/3. Let's see here. 2/3. And you could have also came to this answer through a different way. You could have compared the two likelihoods. You could have compared the this likelihood right here, the probability that the warden would say B, knowing that A would be pardoned, versus the probability that the warden would say B, knowing that C would be pardoned. So let's make a little bit of room. Let's erase some of this down here. Oops. All right. So if we had compared these two likelihoods right here, this is also called the likelihood ratio test. If you compare the probability that the warden would say B, knowing that A would be pardoned, against the probability that the warden would say B, knowing that C would be pardoned, you would see that it's 0.5 divided by 1. Or, in other words, C has twice the chance of being pardoned knowing that B is going to be executed than A. So you can also think of it as, so C is, we can also write this algebraically as 2x, being x being some probability. So this is C's, this represents C right here. So it's 2x plus x is equal to 100%. This guy right here, this x represents A's chances of being pardoned. So then x is equal to, let's see, 100 over 3, or x is equal to 1/3. Let's see, or 30, yeah, 1/3, or 33%. So C's chances of surviving, knowing that B will be executed, is 2x times 1/3, which is, let's make a little bit more room, which will be 2/3. So you could have gotten the answer that way as well. 2x equals to 2/3. And the intuitive way to think about this, there's also another intuitive way to think about this. It's a little hand-wavy, but I think it captures the intuition pretty well. One definition of information can be considered how surprised you are by the fact that's given to you. So if you're given some kind of fact that you know already that you're not even remotely surprised, then it's not considered information. In this case, A had framed his statements to the warden in such a way that the warden would tell A with 100% probability the answer would have been either B or C that would be executed. So from A's point of view, there was actually no surprise. So from his point of view, he actually didn't get any kind of information. That means that he actually, from his point of view, he could have had this conversation in his head and it would have had the same result. So that's why there's no update to his probability. But because there's no update to his probability, but one of the probability has been eliminated, B's chances of being pardoned has been eliminated, then C's probability has actually been updated. So that's also another way to think about it.